Hello everyone. So today we are solving a question of JEE Advanced 2020 from the topic of fluid mechanics. So first read the question as it says that they're given some two vessels which have water as solution and they have KMnO4 as their solute. There is some difference between their concentration which is given as N1 and N2 and the delta N is equal to N1 minus N2 which is very less than the N1. When they are connected in a small tube of length and the cross-sectional area S, they start to diffuse from left to the right vessel. Consider the collection of molecules to be like we have to consider them as ideal gases and write the equation according to that, and it experiences a viscous force of beta V on each molecule, neglecting all the terms of the order delta n square. So we have to solve this question. So let's first mark out what we have to find here. First of all, we have to find out the driving force. We will report, like, denote as FD. Then we have to find the friction force or the force which balances here, or like friction force is not a good term, we can use a viscous force, that is FV. And now like the rate of transfer of molecules, that is total number of molecules going cross tube per second, that we can denote as that I'll see later. And we have to check for option D whether the rate of molecules will decrease or not by with the time. Okay, so let's start doing the equations here. So as we know, what can be the force here, the driving force, we know that the force is nothing but it is equal to pressure times the area. Okay, so from as it is given that we can consider them as dilute ideal gases, so we can write the equation of PV equal to nRT. Okay, where N is number of moles and V is the volume and P is the pressure, R is the gas constant and T is the temperature here. So we can write for this vessel P1 is equal to N. What will be N by V here? That this is the thing we have to consider. N is the let me check. N is given as the molecules per unit volume. So molecules per unit volume, we do not want molecules per unit volume, but we want to make it moles per unit volume. So then this equation will completely satisfy. So what we have to do here, we have to make N by N by V will be equal to N1 by Na, as this is the number of molecules, and if we divide it by Avogadro number, we will get the number of moles here. So N by V we can make it as N1 by Na, okay, times RT. And similarly for the vessel 2, we can write P2 is equal to N2 by Na into RT. And we know that R by Na is nothing but the Boltzmann constant, that is Kb. Kb is given as Boltzmann constant. So we can write it as Boltzmann constant. So P1 is equal to N1 kBt and P2 is equal to N2 kBt. Now, as I told you earlier, the force can be, that is, it will be equal to delta P times the area here. So what is delta P? It will be P2 minus P1, that is N2, or whatever will the greater, yeah, N1 minus N2, N1 minus N2 times kBt. N1 minus N2 is given as delta N, so delta N kBt. And what is the area here? Area is given as S, the area of cross section. So we can write it as S. So this is our driving force, which is equal to delta N kBTS. So yes, our option A is correct. Now moving on to the next option, that the force balance implies this. Okay, so what will be the balancing force here? We know that, suppose if this is a tube, okay, and it is given that each of the molecule is experiencing a force of beta V. So for total force, what we have to do, we have to first write N1 beta V. This is the total force experienced by the concentration among them, and to find all the forces, we have to multiply it with the volume. Like this is the force acting on this much concentration, or like we can say a unit volume. On a unit volume, this much force is acting. So we have to multiply it with the total volume to get the net force acting, okay, on it. So to find it, what we can do here, we'll erase all this and take beta V into what will be the volume there. So N1 beta V, what will the volume? It will be nothing but L into S. This is the length and this is the area. So it will give us the volume here. Now this should be equal to what we have found earlier, that is delta n kBTS, delta n kBTS, cancelling as both sides. So we get N1 beta V into L is equal to delta n kV. So yes, this implied this, hence we can say that our option B is also correct. Now moving on to option C. So the total number of molecules going across the tube per second. So how can we calculate it? The total number of molecules is nothing but, if like, let's first define the total number of molecule. It will be nothing but N1 into what will be the volume, L into S, and what is their speed? It is nothing but dl by dt, or dl by dt is nothing but the V only. So N1 into V into S. Sorry, like we should not write L here, because like if you suppose this is the area of like if we consider some small radius of dr here, okay, so they are moving with the speed of dr by dt. So to do this, this will be the net the number of molecules moving per second, okay. So now we can find V from here and put it in this equation. So N1 into delta n kb by N1 beta L. Okay, I think this will be sufficient. Okay, so N1 into what is V? V is delta n kb by N1 into beta into L into S. Cancelling N1, we can get that the rate of transfer is delta n by, let me check the option, delta n by L, kBt by beta and S. Yes, we got the same, delta n by beta, kb by L, and I think I missed something, T here. Okay, T should be here, and then T S. Okay, so yes, our option C is also correct here. Now for the D, I would like to discuss that it is completely dependent on delta n here. Delta n, like we can clearly see the rate of the transfer of molecule is dependent on delta n. So we know that after some time the concentration will change. Obviously, delta n will keep decreasing here because they are transferring. So delta n will keep decreasing here. So as it decreases, so it is time dependent, because by the time it will not be remaining the same. Hence, we can mark D as incorrect, and we get option A, B, and C as our correct options.